Hey there, this is the third part of the review for the quadratics unit. Okay, starting with number 19, we're going to start solving radical equations. So, in number 19, we have the square root of x squared plus 3 equals x plus 3. So, we have to get that x squared out from under the radical, so the only way to undo square rooting is by squaring. Okay, and as you can see, that's what I did there. Now, I'm going to do x plus 3 times x plus 3 on the right-hand side. Notice that the left side, the radical just goes away. But on the right-hand side, I actually have to repeat that multiplication like that. Okay? So, that gives me x squared plus 3 on the left equals x squared plus 3x, okay, plus 3x plus 9. Okay, remember that is not x squared plus 9. Okay, you have to have that middle part in there. Okay, so that simplifies to x squared plus 6x plus 9. So, subtract x squared from both sides, and voila. This problem is very, very manageable. We get 3 equals 6x plus 9. So, add 9 to both sides. Divide both sides by 6, and we find out that x is negative 1. However, when you plug that in, you find that negative 1 works, so negative 1 is a solution. Okay. Now, number 20. We get the square root of x plus 2 equals x minus 4. So this one starts off very, very similar. Okay, square both sides. Repeat the multiplication. Notice that when I squared the square root, the radical went away. Okay. Foil the right side. X times x is x squared. Negative 4 times x is negative 4x. Okay. X times negative 4 is negative 4x. Negative 4 times negative 4 is 16. And then clean it up. You get x plus 2 equals x squared minus 8x plus 16. So now I need to get everything on one side, so I'm going to subtract x from both sides. Okay. Over here, that leaves me with 2 equals x squared minus 9x plus 16. So now I'm going to minus 2 from both sides. Okay. Just like I did here. Very, very common mistake. You've subtracted everything away. Well, what's left? It has to equal something. Well, it has to equal 0. Okay. Most common mistake I see made is people subtract everything away and they don't know that 0 represents nothing. Okay. So now you can either choose to foil it, choose to factor it, or you can quadratic formula it. Okay. This one's not bad because negative 2 times negative 7 is positive 14. Negative 2 plus negative 7 is negative 9. Okay, now set each of these equal to 0. And you add 2 to both sides, you get x equals 2. Add 7 to both sides, you get x equals 7. But 2 minus 4 gives you a negative number, so 2 does not work. So, we have an extraneous solution. Would we do that on a test to you? Oh yeah, it's coming. It's happening. It's there. Believe it. Trust it. Okay, so, starting with number 21 now. Okay, in number 21, okay, we have 4 times the square root of x plus 9 equals 20. Well, I'm going to divide both sides by 4 to get the radical by itself. So I get x plus 9 equals 5. So divide both sides by 4. So divide both sides by 4, and I get square root of x squared plus 9 equals 5. Now it's time to square both sides. Undo the square root. Okay? So that's what I did there. The square and the square root cancel each other out. 5 squared is 25, so I'm going to subtract 9 from both sides. I get x equals 16. And if you plug 16 in for x, you're going to find out that it does indeed work as a solution. Number 22. Okay. Now, we have a radical equals a negative number. At this point, if you see that, you can stop and say, no solution. Okay? You cannot solve this problem, okay, no matter what you do. Now, algebraically speaking, yes, we could square both sides, okay? And that would give us x squared minus 15 equals negative 1 squared is 1. You could add 16 to both sides. So you could add 15 to both sides to get 16. Square root of 16 is positive or negative 4. But when you plug that in, okay, you get 16 minus 5, and the square root of 1 is not negative 1. So, sorry, that one has no solution, period. Okay, and last problem in that section is number 23. So, the square root of x plus 4 plus 6 equals 9. So get the radical by itself. Subtract 6 from both sides. Well, that gives me the square root of x plus 4 equals 3. Now it's time to get rid of the radical. Square both sides. The square root of x plus 4 squared equals 3 squared. So the radical and the squareds cancel. 3 squared is 9. Subtract 4 from both sides. We get x equals 5. So that problem works. You can plug that back in and check. 5 plus 4 is 9. Square root of 9 is 3. 3 plus 6 is 9. So that one is finished for us. Okay. Now, the last question out of the radical section is number 24. But this one's a word problem, so technically it's not really part of the section, but it is. So they give me the formula, and they ask me to solve that formula for v. Well, first thing I have to do is because v is under the radical, I have to get rid of the radical. So I'm going to square both sides. Okay, squaring undoes the radical, so no more radical. Now, v is being divided by pi times h. So I'm going to multiply both sides by pi times h. Now, pi and h are just numbers, so you can go ahead and cancel them out. Okay. And we're left with pi times r squared h equals 3v. Well, get v by itself. Divide both sides by 3. Okay. Over here, the 3's cancel. And so I'm left with v equals pi r squared h divided by 3. Okay, so that's what I need for part B. Okay, there's my formula. Okay, they want me to find out what is the volume when the radius is 6 and the height is 5. So I just plug in pi times 6 squared times 5, then divided by 3. I just plug it in my formula that I found. So type 6 squared times 5 into a calculator, divide that by 3, and you get 60. And then the pi just comes along for the ride. Okay. That is the last question in that section. Okay. In the next video, we'll review the section that deals with imaginary and complex numbers. So, click the link.